Okay, let's start. Okay, 6.5 optical instrument. Okay, uses of lens in optical instrument. Okay, so this one use the lens as magnifying glass. Okay, as magnifying glass, and then use the lens as telescope. Okay, magnifying glass. This is the same lah. Okay, this one is as microscope. This one is microscope also. So that means generally here what we are going to learn is how is it that we can use the lens for as magnifying glass, as a telescope, and also as microscope. Okay, so that is the three main application lah. Okay, using lens in as a magnifying glass, as telescope, and microscope. Okay, so first we want to look if it is as magnifying glass. Okay, magnifying glass. Okay, so for magnifying glass, all we need to do is we just use one convex lens. Okay, this is all that we need. Okay, one convex lens. We take one convex lens and we put the object. All we need is we just take the object. Okay, if we just put the object between focal point and the lens, okay, anywhere between the focal length and the lens, then we will be able to magnify the image. Okay, straight in, pass through focal, second ray, pass through optical center. So this is where the image will form. Okay, this is the location of the image. If you look from here, okay, look from here, from the eye of the observer. Okay, the light come from the object, pass through the lens, go in this direction. The light from the object go through the lens, go in this direction. So from the point of view, okay, of the observer, it looks like the light come from here. Okay, looks like the light come from here. Okay, looks like come from here. So the image is here. So you can see that the image is bigger than the object. Okay, magnified. So this is how we use the convex lens as magnifying glass. Okay, so the condition is we use convex lens. It must be convex lens, and then object between F and optical center. Okay, just like that, and then we will be able to produce. Okay, we're able to produce magnified image, upright, and virtual. Actually, whether virtual or not is not important because for magnifying glass, the most important is the image is upright. The image is magnified. That is the first thing lah. We want to have magnified image that is bigger, and we want it to be upright. Why is it that upright is very important? Okay, produce magnified image, produce upright image. Why upright image is important? Important because same orientation as object. Words, image of words will not be inverted. So you understand the importance of having upright image. If the image is upright, then that means it has the same orientation as the object. So that means if you use the magnifying glass to look at things like words, you want to observe object where the orientation is very important. For example, words. Then the upright image is very important, because if it is inverted, inverted, then you cannot read, right? Very difficult to observe, very difficult to read if it is if the word is upside down. So this is the importance of why is it that we need to put the when we use magnifying glass, the object must be between F and O and the optical center, so that the image is magnified upright. Magnified and upright. If we just want the image to be magnified, we can just put this between F and 2F. If we put between F and 2F, we can also get magnified image, but the problem is the image is inverted. The image is real, it is inverted. So although we get magnified image, if between F and 2F, let's say this is 2F. Between F and 2F, if the object is here, if the object is between F and 2F, then we get magnified but inverted image. So it's not so suitable for magnifying glass. Alright. So I repeat, to summarize, magnifying glass is basically just one convex lens. You just take one convex lens and you put the object between the focal point and optical center, then you can get an image that is magnified and upright. Then the convex lens is functioning as magnifying glass. Just like that. Alright. So next we want to look at designing and building compound microscope and telescope using convex lenses. So here we have compound microscope.